Hi, I'm Tom Mooney with Emerson Process Management. As we talk to our customers, we find that many of them would like to enjoy the benefits of ultrasonic flow metering in non-custody transfer type applications. Today, I would like to introduce to you the new Daniel Model 3812 liquid ultrasonic meter for non-custody transfer applications. These applications would be applications such as allocation metering, leak detection, batching, and a range of other applications where accuracy is not the primary concern, but high performance, reliable technology is absolutely critical. Ultrasonic meters offer customers a host of benefits that help reduce both capital cost and also operational costs. And today I would like to spend a few moments taking you through several of the features of the new 3812 to show you how customers can save on capital and operational costs. First, I'll explain to you how the meter's high capacity and rangeability can afford reduced station footprint. Secondly, I'll talk about how the fact there are no moving parts or protrusions into the flow reduces wear and reduces maintenance on the product. And third, I'll explain to you how the product is easily serviced in the field through field replaceable transducers. Okay, so first I'd like to explain to you how the ultrasonic meter can give you high capacity and increased rangeability when compared with traditional technologies. For example, the ultrasonic meter, as you can see, is a very simple device. We have the meter body here, we have our electronics here, and we have transducers which are located under this housing here. The 3812 is a two-path device. Two paths meaning there are two locations in the flow where we are measuring the flow rate of the liquid. The meter measures the flow rate of the liquid by firing pulses of sound with and against the flow. As a pulse of sound is fired with the flow, it tends to travel slightly faster than the speed of sound. As it's fired against the flow, it tends to travel slightly slower than the speed of sound. The difference between these two transit times is related to the flow rate of the liquid. So by measuring this flow rate on two separate paths, we can basically generate the average flow rate of the fluid flowing in the pipeline. There are no moving parts in the product, there are no protrusions, there are no obstructions. So this basically means that the fluid can pass through the meter at the capacity of the pipeline itself. There is no restriction in the meter, there is no limiting factor in the meter that curtails the capacity of the system. Secondly, when you compare the liquid ultrasonic meter to a conventional technology, say for example PD meters, then there are no friction, no bearings or no rotors that generate friction that have to be overcome. This means that the rangeability of the meter is also extended at the bottom end. So when we compare the ultrasonic meter versus a PD meter, for example, we can see that we can operate with a much smaller ultrasonic meter than would be required if we were using a PD meter for that application. Okay, so let's take an example of a process requirement where an operator is looking to measure 3,500 barrels per hour of light crude oil. To satisfy this application, using a conventional PD meter would require a 10-inch device. This process could be addressed using a 6-inch 3812 meter. Moreover, the 3812 would give us a capacity of 6,500 barrels per hour, which gives a significant overrange to the operator. So we can see that using the 3812 relative to a conventional PD meter allows us to go with a much smaller device. This much smaller device not only means a smaller pipeline or smaller diameter pipeline, but also means smaller valves, smaller ancillary equipment, smaller footprint, which are all critical factors, especially in offshore applications where space and weight are of a premium. And speaking about weight, when we compare the weight of the PD meter, so the 10-inch PD meter, with the 6-inch ultrasonic meter, the PD meter weighs approximately 4,000 pounds, whereas the 3812 ultrasonic weighs approximately 450 pounds. So there is a huge saving there as well in terms of weight. Okay, so we've discussed the fact that the 3812 gives us excellent capacity and excellent rangeability, affording reduced station footprint and also reduced metering station weight. Now let's talk about how the 3812 can actually offer reduced operating costs for operators and oil producers. As we mentioned before, there are no protrusions in the meter, no moving parts, nothing to wear. So this basically reduces the amount of maintenance that has to be performed on the meter. With no moving parts, then essentially there's nothing to be replaced. And so we no longer have to do our maintenance on a prescriptive basis, but in fact we can start to examine the meter more on a condition-based approach. Okay. Another way in which the ultrasonic meter can save operational costs is given the fact there is no incremental pressure drop from this device. So no extra pressure drop means reduced pumping costs for operators. If we go back to the example of the PD meter, in that example of 3,500 barrels per hour going through a 10-inch PD meter, that was generating an incremental 4 psi of pressure drop in the system. With that same process going through the 6-inch 3812, we were generating an incremental 0.4 psi. So that reduced incremental pressure drop means smaller pumps, means less pumping costs, and again contributes towards the overall operational cost savings of the product. Okay, so now we've discussed the capital costs that the meter can afford you. We've also just discussed the operational costs. Now let's talk about how we can service this meter in the event that there is an upset in the field. If there's an upset in the field, the most likely instance that will be is through a transducer problem. Now, transducers can be replaced in the field in the unlikely event something goes wrong without any downtime in the process. So let me just demonstrate to you how the transducer is actually constructed. This section here is the transducer holder, and this section that I'm unscrewing just now is the transducer retaining ring. The transducer itself is actually located inside the transducer holder, and it doesn't actually see any of the process. The transducer housing is actually the pressure retaining part, and this is the wetted part that's in contact with the process. So, in the unlikely event that something goes wrong with the transducer, we can come along, we can remove the retaining ring, we can extract the transducer, make an exchange, and then place the new transducer back inside the existing pressure retaining ring. There is no need for us to depressurize the line. There is no need for us to power off the meter, because the transducer housing is acting as the pressure retaining part, and the transducer itself is an intrinsically safe design and basically doesn't have enough energy there to create a hazard in the field. Okay, so today we've talked about the new 3812, and we've explained how, through its high capacity and high rangeability, it can reduce the footprint for metering installations, which is particularly important offshore. Moreover, we have discussed that the fact there are no moving parts, no additional pressure drop, this can reduce costs for operators. And lastly, we've discussed that how the ultrasonic meter can be serviced in the field without any downtime, without depressurising the line, or without in fact losing any measurement. I hope you've enjoyed this short discussion on the 3812. I look forward to seeing you again, and if you require any information, please feel free to contact your local Emerson representative or visit us at the Emerson website. Thanks very much.